Okay, so the recording has started now. And as I've said earlier, our tag is on data modeling in Power BI. We have our facilitator here. And so data modeling is an essential aspect in Microsoft Power BI for anyone looking to transition and anyone using Power BI. Without data modeling, you cannot have an effective and a well-structured data. It's always very, very important to ensure that you have that. It's always very, very important. And we have participants joining us from different locations. And then at first, we don't want to really waste our time because our facilitator has a well-structured plan he has brought for us from a slide and the practical section as well. So we have participants joining us from different sections and location, and we would like to know everyone that are connected from us. So before we begin, let us make this section interactive, just a few minutes. So I'd like to call some people to introduce themselves and let us know your name, your location, and what you hope to learn today. Right. So so if anyone interested, I just only 3 people. Then from there we'll pick it up. Anyone interested, guys? Anyone? Let us know your name, your location, and where you are joining us from. Your name, your location, and where you are joining us from.
Yeah, good afternoon, everyone.
Good
My name
afternoon.
is Kola Ole. I'm joining from Lagos State, Nigeria. So my sole aim today, because this is my first time of having this kind of session concerning Power BI. So I hope I'm able to learn one or two today in this session.
That's very great. I really hope you will enjoying a lot from our facilitator. He's a certified data analyst, and yeah. So if you check his if you check his profile on LinkedIn, he has been attending to a lot of challenges, winning, being the best of most of the challenges on LinkedIn. So I'm very sure you are going to learn effectively from him. Right. So another person as well. Guys, let's see another person. Let's have another female also. Let's another female or another person. What do you hope to learn from this masterclass? Yeah. Anyone again? Anyone? Yeah. Okay. Curtis, you can go ahead. You can go ahead.
Hello, Mr. Oladosu. Good evening, everybody. This is Felix joining from the Congo, Democratic Republic of the Congo. And I am glad to be part of this masterclass. I have to confess that it's not my very first masterclass organized by the CodeSphere Hub. I'm glad to be part of this, and I expect to strengthen my abilities to model data, as I have understood that this is the basic of any data visualization process. Thank you.
Yeah, thank you so much for that. And I hope perfectly you also learn and gain a lot from our facilitator. And thank you for joining us from Congo. Yeah, so another person once again. So we can move on the section. Another person once again.
Hello.
Yeah. Good afternoon. Yeah, Gulam, you can go ahead.
Good afternoon, sir. Kindly let me know about if you provide a certificate of this course.
Certification on this course is not on this years. This is just a master class, right? So, we are not providing certification on this yet. This is just a master class.
You cannot provide a certificate.
Yeah, what do you say?
I think, but I know about that in the last live class you can provide a certificates.
Yes, but not for this. Not for this. This is just a day master class.
Okay.
Thank you. Thank you. Yeah, so in order to waste much of our time, so thank you guys, and as we go to today's section, I encourage everyone to participate actively. Don't just listening, guys. Ask question, take notes, follow the practical demonstration, and feel free, feel free, feel free to share your thoughts in the chat as well. So if you have any questions, during the section, ensure you drop them after. Ensure note it down, and then after the explanation from the facilitator, you can get to us. So make sure that we address at the appropriate time. Right. So today's masterclass is designed to be practical, and so I encourage everyone to stay engaged throughout the section. And likewise, at the end, before you guys leave, we will appreciate your feedback. Right, we appreciate your feedback. A Google form will be sent by the admin. So you take a minute to complete the testimony and feedback form. We'd love to know, what did you learn from today's masterclass? What was your biggest takeaway? How useful this section to you? And then what would you likewise, and what will you also like us to cover in the future for this section? And it is from this feedback that we help to understand what is working and how we can continue improving on most of our programs. Thank you. Now, so it's my pleasure to start to introduce our today facilitator. Our facilitator for today masterclass, Mr. AbdulSamad Kudehinbu, is already here with us. Will be taking us to designing scalable semantic models using Star Schema based practices. So we are looking forward to learning from his experience, his practical knowledge of Power BI and data modeling as well. So Mr. AbdulSamad, so let us all welcome Mr. AbdulSamad. Let us all welcome him. Let us all welcome him, guys. Let us all welcome him. So
All right.
The is over to you now, and thank you so much.
All right. Good evening, everyone. Like Mr. Ibrahim has introduced me, I am AbdulSamad Kudehinbu. I am a Power BI developer and a BI analyst, and I am also.
Sorry for cutting short, Mr. AbdulSamad. Likewise, before the ending of this program, we have a cohort coming up. And I want each and everyone to please ensure you stay till the end. Ensure you stay till the end, right? So a cohort is coming up, which myself, I see it as a bonus for anyone who wants to learn Power BI from beginner level to the advanced level. From beginner level to the advanced level. Most of the time, I don't really recommend academy like that, but I can guarantee and give recommendation pertaining to anyone, go to this. So our facilitator will soon be having a Power BI bootcamp coming up, right? It's fully full package. It's a full package whereby you learn Power Query, you learn data modeling, you learn your DAX. We have a lot of people of which, as a data analyst, they don't really understand DAX. Right. Even though if you don't understand data modeling, you really have problem with your dashboard. You really have problem analyzing some other things when you get to your building your dashboard. And then I'm very sure you really be convinced from his masterclass today. I'm very, very certain you really be convinced from his masterclass today. He is a top-notch instructor when referring to data analysis aspects. He's a top-notch instructor when referring to data analysis aspects, and he's having his masterclass by October. So each and everyone, I'll be after his section, I'll be showing you guys the link, the registration to register, the flyer for each and everyone. So you can do well to register for you to know more about Microsoft Power BI. Yeah, so we also have lots of more masterclass coming up. right? So, AbdulSamad, thank you so much. Over to you now.
All right. Thank you, Mr. Oladosu. Okay, so I am AbdulSamad Kudehinbu. I'm a Power BI developer and a data analyst, also a BI analyst, and I am the assistant head of data at CodeSphere Hub. All right, so today I will be walking you guys through one of the most confusing and most technical parts of Power BI. Although data modeling being technical is more minutes, right? It is more of, one of those simple but not easy concepts. So it is simple in the sense that it is, it is straightforward. Just, need to understand how it works. And from there, you can just, build and scale on. So today we'll be looking at data modeling in Power BI. What is it all about? All right. So what are we going to cover today? We're going to cover how Power BI works generally, the importance of data modeling. Then we'll be looking at, the concepts of data modeling from our fact tables, dimension tables, primary keys, foreign keys. Then we'll also be having hands-on practice to, see how it works really. Then we'll also be talking about the do's and don'ts when it comes to, modeling your tables in Power BI. All right, so the first question is where does data modeling fit? So like, what is the entire data modeling process about? So when it comes to working with Power BI, right, working on a Power BI project, you have to think of working with Power BI in terms of working with a workflow, right? So there are certain things you need to do before you do certain things. So everything you do in Power BI can be divided into 6 stages, or you can call them steps, or you can just call them processes in a workflow. So it is a workflow because each stage depends on the previous stage, right? So there are 6 processes in this workflow. And the first process is the connect process. So obviously, if you want to analyze data in Power BI, you need to get your data from somewhere, right? So the process of connecting to that data source and bringing the data into Power BI, that is the connect process. So you do that by going to get data in Power BI, then you bring in your data. So depending on, the connection you use, whether this import, direct query. So all that is, a different topic on its own. But, just bringing your data, that is the connect phase. And after you've brought in your data, most likely the data won't be, perfect for analysis, right? Even if it is clean, sometimes you still need to, transform it in such a way that you get the exact, format you want to use to analyze your data. So the process of, you cleaning the data, then transforming it to the exact way you want, that process is called the transform process, and it is done inside the Power Query editor. So after you've connected to your data source, you've transformed the data, the next step is to model the data. So data modeling is, just creating relationships between your different data sources so that they all act as as a unit. And after you model your data, you've created your relationships. The next step is to analyze your data. This is where you write your DAX. You find your averages, your totals. So all that is the analyze process of the workflow. And after analyzing your data, you visualize your insights. So this is where you build your reports, your line charts, your bar charts, your KPI cards. Then after building your reports, you then publish to Power BI service. So these are the 6 processes in the Power BI workflow. And today we'll be focusing on just one of the process, which is the model workflow. So the model process. So what is data modeling? Data modeling is is the process of connecting to different data sources, linking them together using matching columns, and then creating rules so that they share information and act as a unit. So this is very important because everything you do after the data modeling step depends on the data modeling. So If your data model is wrong, even if you carry out the best analysis practice, you write the best DAX, you use the best charts in your reports, and you publish, if your data modeling is wrong, every other thing downhill is what is wrong. So remember, it is a workflow. Same way the remaining processes depend on your model. Your model, I mean, how good your data model is also depends on your what, how well you transform your data. So each subsequent stage of the what, of the workflow depends on the what, on the initial one. So how good your transformation is depends on, how well you connected to your data. So it all depends on the what, how good, each of the process in the workflow is. All right, so now that we know what data modeling is, let's see the importance of what data modeling. So why does it what matter? So the first importance of data modeling is what? Is speed. So Power BI works faster when your what tables are what organized and what their relationships between them. Just think of it as as a normal human being, not just in Power BI right now. So just like a normal human being, right? When you're working on a project, if your the tools are using to work, right, or the files you're working with, if they're organized, right, and there are relationships between them, you'll work faster, right, compared to when everything is just disorganized and what distorted. So data modeling is act of creating that organization and what relationships between your tables. So a good data model leads to what? A faster workflow in Power BI. Then second importance is what? Accuracy. So good connections between your tables stop the numbers from being wrong. Why? Because you've created relationships between your tables. Those relationships, they kind of make sure that you have the same answer irrespective of how you write your DAX. Because when it comes to DAX, there are different ways you can get the same answer, and that depends on your level of expertise when it comes to DAX. So modeling your data the correct way makes sure that your numbers are right, irrespective of the way you write your DAX. Then you have simplicity. A clean model makes your formula simple and easy to read and write. Then lastly, you have room to grow. So another importance of data modeling is that when you are working in an organization where your data is growing constantly, when you have a good model in place, you do not need to always come back when new data enters the system. So once you've already built the correct model in place, when new data comes in, it just slots in perfectly. Rather than when your design is, your model design is wrong, then it means you always have to come back to change one or two things. But once you design the data model perfectly, you don't need to come back. So it works automatically. All right, so now let's see the cost of a messy table. So let's see the difference between using one giant flat table and using a well-organized star schema. All right, so if you're someone that has worked with Excel a lot, you'll be conversant with something called a giant flat table. So a flat table means all your data is inside one single table. All your data. So for example, if you're working with a sales data set, that means your customer data, your location data, your promotion data, your product data is all under one fact table. So now, while this might look good, in the sense that you have all your information in one table, to Power BI, it is a lot of work and a lot of stress. The reason is that if Power BI is looking to calculate one thing, Power BI needs to look at the entire giant flat table to just pick out just that one thing, compared to when you're working with a properly modeled. So when working with a star schema, you have data separated into different tables. So you have your fact sales or your sales table that contains information just about sales. You have your customer table that contains information about just one customer. So if Power BI is looking for information about just a customer, for example, Power BI knows exactly where to look, right? So it knows that it just needs to go to the customer table. compared to using what one giant flat table where Power BI needs to start searching for where that customer is. So that is why it is very, very important to understand data modeling, not just in Power BI, but in other tools too. In your Excel, for example. So sometimes when you're giving data, it won't always come in a giant flat table, right? So most of the time it will come in a schema. And if you are someone that is not conversant with data modeling, that would mean you would have to start using your in Excel, you have to start using your mesh queries in Power Query. And that is, you compounding all the tables together when you can just work with them differently. Then you just have to model them and, go ahead with your analysis. So that is what this, masterclass is all about. How to create a Star Schema and model your data using best practices. All right, so now let's look at the difference between fact and dimension tables. So every model in Power BI is built from just this two tables. So if your data is not coming in as a giant flat table, it means it's coming in in a schema form. When it's coming in a schema form, you usually have two different types of table. So it is either the table is a fact table or the table is a dimension table. So what's the difference between the two of them? So the fact table is the table that contains the numbers, right? So say for example, we are working with a sales data set, which is what we are using in this masterclass. So the fact table is the table that contains the quantitative or the numerical measures. So if it is a sales table, for example, the fact table will be the one that contains, the revenue, the cost, the units sold, the discount, all those measures that you can keep track of. So they are all housed in the fact sales table. And it also, so when it comes to the fact table, in this case, our fact sales, one row represents every single cell. So if it comes to our data, for example, so data set we'll be working with today has 9 different tables. So we have one fact table and 8 dimension tables. So this is our fact table called fact sales. So the fact table, like I said, it contains numerical information about each single cell. So we have the quantity sold, the unit price, the discount, the net unit price, the sales amount. So the fact table is a table that contains values that you can track. But the fact table does not just contain that; it also contains your foreign keys, and it also contains the primary key. So we'll be looking at what primary keys and foreign keys are later on today. But for now, just know that the fact sales table is the table that contains the information that you can track, which are usually your numbers. Then we also have the dimension tables. The dimension tables are the tables that hold specific details. They are the tables that contain the qualitative or the descriptive data. So there are tables that hold details such as who, what, where, and when. So these tables are the ones that usually start with DIM. So for example, you have DIM customer, DIM product, DIM date. So DIM customer means dimension customer. Why fact sales means fact sales. So DIM customer, for example, would contain information just about the customers. So for example, we have DIM product, right? So DIM product would contain information about the product. So for example, we have the product category, the product subcategory, the product name, the standard, the list price of the product, the unit cost of the product. Then we go to DIM channel, which will contain information just about the channels. We come to DIM geography, contain information just about the geography. That is the difference between the fact sales table and the dimension tables. So what we'll be learning today is how to connect the fact tables to the dimension tables, so that they all act as a unit and they don't act independently. Because without connecting them, they are just independent data sources. Although they might be in the same worksheet, but without proper data modeling, They are acting as what? Independent what? Data sources. So data modeling is, in summary, is the process of what? Connecting what? Those tables together so that they all act as what? As a unit. All right. So now let's look at primary keys and what? Foreign keys. So the primary keys and foreign keys, they're basically how what? The tables connect to each other. So what is a primary key? The primary key is a column that what makes each column, makes each row unique. So think of the primary key as an NIN, right? So say, for example, you have access into the NIN database, right? So for every citizen in a country, or in Nigeria, for example, each citizen would have what? Its own NIN. And no two citizens can have the same what? NIN. So if that happens, that means there's a duplicate. That means one person is existing twice inside the database. So they need to take one out. So that is what the primary key does. It makes each row in the table unique. So every table should have a primary key, whether it is a fact table or a dimension table. So for example, our fact sales table is the table containing information about our sales. So the primary key for our fact table is this sales line key. So if you look at it, so this is the primary, the sales line key for the first sale, which is 1. So if we click on the filter in Excel and we scroll to the end, we won't find any other sales line key, which is 1. So 1 appears only once. So this is the unique identifier for this particular sale on this line. So same as the dim date. So the dim date has the date key as the primary key. The dim geography, it has the geography key as the primary key. The primary key is that column that serves as a unique identifier for each row in the data set. So it is what makes each row unique. Then we have the foreign key. So the foreign key are basically the primary keys from your dimension tables that are found in the fact tables. So it is the matching column in the fact table, and it points back to the dimensions key. What does this mean? So when we come back to our data set, for example, so if we look at dim geography, that is a dimension table for the geography. The primary key is geography key, right? So this is the key that makes each geography or each location unique. If you come to the fact sales, we'll also find the geography key in the fact sales table. So this geography key in the fact sales table is called a foreign key, while in the dim geography table is called a primary key. So the main essence of primary keys and foreign keys, beyond their primary work, which is to uniquely identify each row in the dimension table, their other job is to create relationships between the fact and the dimension tables. So this is what we are going to use to create those relationships. So if you are someone familiar with SQL, when you're using your inner join or your left join, you see left join, then you specify the tables, then you have to use the on statement. So for example, you say fact sales dot product ID is equals to dim product dot product ID. So that is basically the same thing we're trying to do here. So we're trying to use the foreign keys and the primary keys to create relationships between the two tables. So that is the second job of the primary and foreign keys. So connect the PK, which is the primary key, to the FK, which is the foreign key, and Power BI knows how the tables relate. So that is basically how relationships are created in Power BI. So you have the customer key, for example, in the customer table, and you have the customer key again in the fact table. So the customer key in the fact table is is an F key, which is the foreign key, and in the dimension table, which is is the PK. So when you connect the two tables together, basically connecting them using the primary key and the foreign key. All right. So the next concept we'll be looking at before we go, to start the data modeling proper is what is a schema. So designing what a schema. So when it comes to designing schemas, we have two main types of schemas. We have the star schema and the what snowflake schema. So they are basically ways to organize your tables in Power BI. Although Power BI usually prefers just one of them. So and the one Power BI prefers is the star schema. So we have both the star schema and the snowflake schema. So the star schema basically means that you have just a single fact table connected to individual dimension tables. While the snowflake schema is similar to the star schema, but in the snowflake schema, you have further sub-dimensions, right? So you have the dim product, being connected to sub-dimension tables. So let me use clearer pictures to show you guys what I mean. So yeah, so this is a star schema, right? So the name comes from the way it looks, right? So when you picture a star, you have a big center, with branches, right? With just singular branches. So that is what the star schema is, right? So you have just one fact table in the center connected to just single dimension tables around it. So you can have multiple dimension tables, right? It doesn't really matter. But what matters is that they are only connected to dimension tables and nothing else. So the dimension tables are connected to only fact tables, and the fact table is connected to only dimension tables. That is what a star schema is. Then you have the snowflake schema. The snowflake schema is similar to the star schema, right? But the dimension tables are further divided into sub-dimension tables, or dimension tables are also linked to other dimension tables. So that's just the difference between the star and the snowflake schema. So in the star schema, you have fewer connections, faster report, because the more connections you make, the more work Power BI has to do. And the more work Power BI has to do, the slower your report. So that is why Power BI prefers the star schema, because they are just fewer connections, and that leads to faster reports and similar formula. I mean simpler formulas. So Power BI uses this by default. Then you have the snowflake schema. So the snowflake schema looks more organized on paper, right? Because it looks more detailed, but it is actually extra work for not just you as a user, but also for Power BI, because there are more connections now, and that means Power BI has to put in more work, and that will lead to slower reports. And the benefit is just little, because whatever you can do with a snowflake schema, you can just achieve the same thing with a star schema. That is why it is very, very important, as much as possible, to go with a star schema instead of a snowflake schema. All right, so why use the star schema? So I thought it's very, very important, to emphasize on using star schema, so that you can see, the advantages that star schema has over snowflake schema. So these are 4 reasons why you should, use star schema when designing your Power BI model. The first reason is that Power BI's engine, which is called the Vertipack engine, it was designed to compress your data as much as possible, so that it can save space. So that is why you will see that you can bring in millions of rows into Power BI, and at the end of your report, you see that your report is just about, let's say, 20 MB or 30 MB space, right? That was because Power BI's engine was designed to do exactly that. So it was designed to compress your data to save space on your system, and it does this best with a star schema. So when you have just few connections within your tables, Power BI is able to efficiently compress that data, compared to when you have when you start dividing your dimension tables into further dimension tables. And that way you're not just creating more data, you're also creating you're not just creating more connections, you're also creating extra data for something that you will get the exact same result if you use a star schema. Then another reason why you should use star schema is that when you use a star schema, the filter only has to travel one step. from the what dimension to the what to the fact table. So that is what easy and what fast. So let me show you what that means. So let's use this diagram for example. So let's use the star schema. So you have the fact table, right? And you have the dimension table. So let's say this dimension table, for example, is a product table, right? I want to say, for example, you want to get, so under the product, let's say I have a product category for electronics, right? So, and inside the fact sales table, you have, let's say you have revenue. So let's say you want to filter for just, you want to see just the revenue for what electronics table, right? So you can easily, when you're using this task, you can easily just come to the dimension table, create a filter and what just filter based on what the dimension table. So that is just one connection. So it filters it what ASAP compared to when you are using a snowflake schema. So let's say, for example, you are now using a snowflake schema, right? And you have the dimensions in the fact table, then you now have further dimensions. So now let's say your electronics category is inside this table right here. So if you want to filter using this table to filter the fact table, that filter would have to travel across 3 different connections compared to the star schemas one. You have to travel through this table, and what through this table. And that's only what makes you what Power BI do more work. And the more work Power BI has to do, the slower your reports. That is another reason why, whenever possible, always try to go with what a star schema. And the third reason is what the formulas are just, your formulas stay short and what easy to read when using what a star schema. So it's just the same thing like I explained here, right? So same thing, just look at it. If you're trying to write what a DAX formula, so when it comes to DAX, there's something called the row context and what the filter context. So same way, if you want to get what a result, if the result you want to try to get is in this table, when Power BI is trying to get you your answer for your DAX, it also has to travel throughout this multiple connections, compared to a star schema where it just has to go through one connection, which is the direct connection between the fact and the dimension tables. And the last reason why you should go with a star schema is that it's just simple, right? It looks less complex than the snowflake schema. And it's not just to you, to Power BI also, it is less complex. So anyone looking at the model can understand it fast, right? Because it's really simple. You have just one fact table and a few dimension tables. So just look at it from Power BI's point of view, right? You have this and you also have this, right? So if these two can give you the exact same thing, which one would you go for? You would obviously go for the simpler one. So that is why you should, as much as possible, if you have the option to pick between the two of them, just go for the star schema. So fewer connections to manage means faster work now, and easier fixes data. So that's also true. When you have issues later on with your data model, it's easier to fix if you use a star schema than if you use a snowflake schema. All right, so now let's bring in our data into Power BI so that we can get the first step out. All right, so since our data is in an Excel workbook, so you can just come to get data, or you can just click on import data from Excel. Then you try to locate where your data is. So I think it's, so B2B sales data set. So let's load our data into Power BI. All right, so we're going to select just the tables we need. So 1, 2, 3. So we'll just select only the tables we need. All right, so the data is pretty much clean, but let's just go to Power Query to see if there is anything, because it is a challenge data and it was pretty much clean on arrival. So let's just see if there's anything we need to change. right, so this is our Power Query editor. So we have our 9 tables loaded, right? Okay, so now we have our fact sales, our dim salesperson that contains information about the salespersons, the dim promotion contains information about promotion, dim product contains information about each product. So just like that. All right, so naturally our foreign keys are meant to be in text, but since they're in numbers, you can just leave them as that. So it's very, very important that what your foreign keys and your primary keys should have the same data type. So what does this mean? So when you come to dim salesperson, we have the salesperson key in the dimension table for salesperson. In the fact sales table, we also have what? The salesperson key. Where is it? Yeah. So you have to make sure that they have the same data type. So the data type here is whole number. The data type here is whole number. So if you want to change it to text, because you can also change it to text because it is just serving as an identifier. So it's not like I say you can carry out the total or the average. So if you're choosing to change it to text, you have to make sure that you also want to change this one here to text also. But if you're leaving it as whole number, that's also fine. You won't be using it for any calculation, so that also works. But the important thing is that your foreign keys and primary keys, they all have the same data type. So we can come here to close and apply so that it loads the data into our data model. So let's wait for that to happen. So it is currently loading the data into our data model. So depending on how large your data is, that might take some time. And also depending on the specifications of your laptop too. All right, so it is downloading it and we can see all our tables here. So now to do anything data modeling, you have to come to the model view. That is where you handle all your data modeling business. So we can close this for now. So we can close this for now and we can. All right, so we can see that Power BI has automatically designed our data model for us. So Power BI, it has this ability to, detect relationships between your tables. But if you notice, it didn't include one of the tables, which is what our dim did. So for the purpose of this class, so sometimes it gets it right and sometimes it gets it wrong. It's not like as if it got it wrong, but it just depends. Sometimes depends on your analysis context, right? So it might be that you want to join two tables on specific columns and not the natural columns that Power BI is joining them on. So for the purpose of this class, we are going to delete all the relationships and build them again from scratch. So to handle your relationships and create relationships between your tables, in the model view, you come to manage relationships and you can see a list of all the relationships that Power BI has automatically detected for us. So I'm going to delete all of them so that we can create each one of them from scratch later on. So we'll just delete. And all right, so before we delete, so once you see a line between your two tables, that's how you know that's is a relationship between your tables. So like we can see, this is a proper Star Schema model, right? So we have the fact table in the middle, and we have it surrounded by dimension tables. Let's go ahead and delete all of them. So we just come here, delete. Yeah, so now we don't have any relationships and there are no lines between our tables. So we'll be building the relationship from scratch later on today. All right, so let's come back to the slides. So that now that we've done that. Okay, so next up, let's talk about cardinality. So this is also a very, very important concept when it comes to data modeling and Power BI. So cardinality sounds like a big word, right? But it just means that how many rows on each table match up to each other, right? So it basically means how many rows in this table can be found in the other table. So we have three types of cardinality. Actually, there are four, but we have, so the fourth one is actually many to one. So it's actually the same as one to many, but just in a different direction. So the first type of cardinality is what? Is the one to many cardinality. So this basically means that what? One value in the first table appears what? Once in the what? In the second table. So let's use table A and B, for example. It basically means that what? One value in table A appears what? Appears once in what? In table B. So let's say, for example, we're trying to join dim products to fact sales. So it means that what? One product ID. So a one-to-one relationship between the dim product and fact sales will mean that what? One product ID in dim product appears only what? Only once in what? In the fact sales table. So this type of relationship is what? Is rare. And if you come across it, it basically means that what? Those two tables should be what? Joined together at what? At once. Because they appear what? Once in the what? In the two tables. So there's no point having what? Two separate tables. So if you come across that situation, it just means that you have to what? Join those tables using your what? Your merge queries in your what? In Power Query. Then next up is what? Is the one-to-many, which is what we'll be using a lot and what you'll be using a lot moving on when you start developing models in Power BI. So it is the most common type of what? Cardinality, right? So it basically means that what? One value in the first table appears what? Multiple times in the what? In the second table. Hence the name one to what? Many. So if we're using the dim product and the fact sales table as an example. So this type of cardinality means that what? One product ID in a dim product table appears many times in the what? In the fact sales what? Table. So let me show you what that means. So if you come to, okay, let's use our table view since we already brought in our data. All right. So if we come to dim product in our table, so we have the product key here, right? So in the dim product, we can only have the product key can only what? Appear what? Once, since it is the what? Is the primary key. But if you come to the fact sales table, right? If you come to the fact sales table, and okay, so if you come to the fact sales table and we come to product key, yeah, and we filter for only product key one, let's see. We'll see that what the product key one appears what? Multiple what? Times in the what? In the fact sales table. So that means that what? While it appears only once in the what? In the product table, which is the dim product, it appears what? Multiple times in the what? In the fact sales table. So when we are creating that relationship between the product table and the fact sales table, we are going to use the what? The one-to-many relationship to tell Power BI that what? The relationship between the dim product and the what? And the fact sales is what? Is a one-to-many relationship. So let me clear this filter so we don't get confused later on. Let me just clear the filter. All right, so that is one-to-many relationship. So many-to-one relationship works the same way, right? So let's say, for example, we are connecting fact sales to dim products. It should be what? A many-to-one relationship. So that means, the product ID appears many times in the fact table, but appears what? Only once in the what? In the dim product table. Although it is best practice to always what? Connect from your what? Dimension table to your what? Your fact table, and not the what? The other way around. Then lastly, you have the what? The many-to-many cardinality type. So this just means that what? Many values in table A appear what? Many times in what? In table B. So like you're already thinking about it, right? It's very confusing, right? Exactly. It is very, very confusing. So it is very, very important. Although you would rarely come across it, right? But if you come across it, it is very, very important that you try to avoid it, as much as you can. Because while it is confusing to the human, it is also confusing to Power BI, and it can give you a lot of confusing results. So if you have this type of relationship many-to-many, it's just most of the time it means that you have duplicates in your data, and you didn't properly carry out your data transformation thoroughly. So if you come across this type of relationship, it's usually a way of Power BI telling you to what? Go back to your what? Transformation and check whether you have what? Duplicates in your fact and dimension tables. All right, so now that we've looked at what cardinality is, we also have another concept called what? The direction, or the what? Cross-filter direction. So this is basically how your filters travel across what? Your relationships. So remember, when it comes to Power BI, you use your what? Your dimension tables to what? Filter the what? The fact tables, because the dimension tables are the tables that contain the qualitative data, or the what? Descriptive data. So for example, if you want to get the total sales for one particular category, the category is in the dimension table, while the sales is in the what? In the fact table. So the cross-filter direction tells Power BI, what direction is your filter going. So you have two types of cross-filter direction. You have the single direction, which is the most used one, and you have the what? The both direction. So the single direction goes from what? The dimension to the what? To the fact sales table. So this filter only flows in what? In one way, right? So from the dimensions to the what? To the fact table. So it is fast and what? Easy to what? Predict, and it is what? The default what? Direction. It is the one you should use by what? By default. So for every relationship you create, you have to set what? The cardinality and the what? Cross-filter direction. So that is why it's important that you understand this what concept, because data modeling is not just about creating relationships between the table. It's also about setting what? The rules. And the rules are the what? Your cardinality and the what? Cross-filter direction. Then you have what? Both directions. So in this case, the filter flows what? Both ways. So this can confuse Power BI and what? Slow things down, because this way, you're basically telling Power BI that you can filter from the dimension to the fact, and also from the what? Fact to the what? Dimension. So you would really need to use this, but when you use it, you have to what? Use it with what? With care, because it can what? Lead to what? Ambiguous results or unexpected what result. So in the best case, just in the best case, what you are going to need most of the times is what? Your single what? Filter direction. All right, so now that we've understood all the concepts that we need to understand when it comes to data modeling, let's go into Power BI and build our model from scratch. All right, so we come to the model view in Power BI. So we have all these tables. So the traditional way of building models in Power BI is just drag the what? The dimension key. Drag the foreign key from the what's it called? From the dimension table and match it with the what? With the fact key. I match it with the primary key in the what? In the fact sales. So for example, if you want to create a relationship between dim geography, so let me zoom in. If you want to create a relationship between dim geography and fact sales, what we are meant to do traditionally is to what? Drag the geography key, which is, so this is the primary key in the dim geography, and we drag it to the what? To the dimension key. We drag it to the foreign key in the what? In the fact sales table. So that automatically gives us what? A pop-up, right? So that is the what? Traditional way to do it. But if you're dealing with a lot of tables, the best way to do it is just come to what? Manage relationships. So if you click on manage relationships, it gives you what? A pop-up. And then you can now go ahead to what? Create your what? Your relationships. So now we click on what? New relationship to create what? A new relationship. So now let's create our first relationship. So let's create it between dim business events and what? Fact sales. So remember, your direction should always go from what? From the dimension table to the what? The fact table. So this is meant to be fact sales, sorry. So you always go from the what? Dimension table to the what? To the fact table. So as we've noticed, Power BI automatically what? Identify the what? The primary and the what? Foreign keys for us. So it is Power BI automatically told us that what? These are the two columns that are meant to what? Create the what? Relationship what? With. But sometimes it what? It identifies the what? The wrong thing. That is why it is important to, understand the concepts of what primary and what foreign keys. So you join your tables from the what, from the dimension to the what, to the fact table, and from the primary to the what, to the foreign key. All right, so now that we've identified our matching columns, the next thing is to what, set the what, the cardinality type. So Power BI has automatically identified that what, it is a what, one to what, many relationship. So we have many to one, one to many, one to one, many, one to many, and what, many to many. So this is a what, a one to what, many relationship, because the business event key appears once in the what, in the dim business event table, and it appears multiple times in the what, in the fact sales tables. Hence, it is a what, one to what, many what relationship. Then we have the cross filter direction. So we have what, single and what, both. So since we want the filter to only flow in one direction from the dimension table to the fact sales table, we'll go with what, single. Then obviously we'll have to make the what, relationship what, active. So sometimes we would have inactive relationships. So we'll be discussing that later on today. But for now, all your default relationships are meant to be what, to be active. So we'll click on save, and Power BI automatically what, creates that what, relationship. So if we come to our model diagram, we would see what, the relationship. So it is usually in form of what, of a line, right? So it is in form of what, of a line. So let me close this first for now. So if I should drag this up a bit, I want to show you guys something. Yeah. So if we zoom in, we'll notice that what, the one side is what's on the what, dim business event table. So that is, and the what, the star. So the star means what, many. So this tells Power BI that what, it is a what, one to what, many relationship. And the arrow is what, pointing towards the what, the fact sales. So this is how, your arrows should point from the what, dimension to the what, to the fact sales table. And also, if we look at the arrow, you see that what, the arrow is what, just what, one arrow, and it is pointing what, from the what, fact to the what, dimension table. So without even looking at the managed relationships, from the relationship line, you should be able to tell the cardinality of the relationship and the what, the direction. So from this, I can tell that it is a what, a one to what, many relationship, and it is a what, a single filter. I mean, it is a single direction what, cross filter. So let's say, for example, we come here and we change the, so let's edit this. So if we edit this relationship and we choose a both, we choose both direction, and we click on OK, we'll notice that what, the arrow here changes to what, the both directions. So that is how you can tell the direction, the cross filter direction of what, of a relationship without having to what, open the manage relationship pane. So let's go back to edit it back to single relationship. So edit it back to single, and we'll click on what, OK. All right, so let's create the next relationship. So remember, from your dimension tables, let's do dim channel next. So fact sales. So it has automatically identified our matching columns, which is what, channel key, our foreign, our dimension key to our what, foreign key. Cardinality should be one to many, and the cross filter direction should be what, single. So it should be what, active. You click on save. So it has created the second relationship to our dim channel. So a new relationship again, from dim customer to fact sales. So it has also identified our matching columns, one to many, single, active. Click on save. Then new relationship. So we're going to skip date for now because it has another what's it called? It has another concept on its own which we'll come back to look at. So we'll skip it for now. So we'll go ahead to dim geography, fact sales. So geography key, one to many, single, active. So we have about 3 more. Yeah, so dim promotion, fact sales. So promotion key, one to many, single, active. Then I think we have just 1 more left. Yeah, so dim salesperson, fact sales. So salesperson key, one to many, single, and active. All right. So let's close this. So we've automatically created the relationships. Okay, we've not done dim products. So dim products. There's dim product. Okay. So fact sales. So product key. Okay. All right. So we've automatically created what the relationships between what our table. So I left it to what just dim dates, right? So when it comes to dim date, we're going to create 2 relationships between the dim date and the what and the fact sales. I'm going to what explain why. So let's see why we have to create 2 relationships between them. So let's see. So the reason why is because what our dim date table is something called what a role-playing dimension what table. So it is basically one table performing what more than what one job. So why is that happening? It's happening because our fact sales table. So if you come back to the table view, our fact sales table contains what 2 what foreign keys. So it contains a date key for order date, and it contains another date key for the what for the ship date. But if you come to our dim date table, we have only one primary date key. So since that is the case, we would have to connect the date key twice to the fact sales table. We have to connect it once to the order date key and another relationship to the ship date key. So now when it comes to connecting tables in Power BI, you can only have one active relationship. So if you want to have 2 relationships to the same table, it means you have to decide which one should be the active relationship and which one should be the inactive relationship. So in this case, we are going to be going with the order date as the active, and the ship date as the inactive relationship. So that is basically what this particular slide is saying, right? So one date table can be used in more than one way, like order date and ship date. So Power BI only allows one active connection between any 2 tables at a time. So any other connection stays switched off until you turn it on inside a formula. And how do you turn on the relationship using the formula? You turn it on using the use relationship function. So let's create the relationship first. So we come to manage relationships as usual. So under new relationship, from dim date to fact sales. So Power BI automatically could not recognize any matching columns for us. So, but we know our matching columns, right? So we know our date keys are our primary key. So for the active relationship, we want to connect our date key to the order date key. So automatically it recognizes a cardinality as one to many, single, and active. So our active relationship is going for the relationship between the date key in the dim date table and the order date key in the fact table. So we click on save. So let's shift this. So yeah, so now we can see that there's a relationship now between our fact sales and our dim date. So now let's create the second relationship between those 2 same tables. So we would say from the dim date to the fact sales. So we select our primary key, which is the date key, and our foreign key this time would be the ship. Where is it? Yeah, the ship date key. So you will notice this time, what we'll be doing before, naturally, it automatically selects this as what as active. But if we try to do this now, it gives us what a warning, right? So it tells us that what there are ambiguous parts between what factors and what dim date. So the reason is for that is because what there's already what an active relationship between what the two tables. So that means any subsequent relationship must be what inactive. So when we uncheck this, everything goes back to normal, and we click on what OK. So your inactive relationship. So once we close this, we have what this. So your inactive relationship also has a line, right? But the line is what a dotted line, while your active relationship has what an actual line, but your inactive relationship takes what dotted line. So that is how you know the difference between what an active relationship and what an inactive relationship. So that is basically our star schema so far. All right, so now the next thing is for us to test our model. And to test our model, we're going to need to write some measures. Let us write a few measures that will enable us test our models. Our model. So it is best practice to keep all your measures in one single table. So I'm going to create that table to do that. So I'll come to modeling, new table. I'll say underscore measures. So I want to keep all my measures in one single table. Say is equals to this. All right. So once I hit enter, it gives me what's a new table for where I can store what my measures. So I'll just create a few what's it called? A few measures so that we can use to test our model. So the first one I would like to create is the gross sale. Gross sales. And this is equals to the sum of our sales amounts from our facts table. So that is the point of creating a measures table so that all your measures can go into one dedicated table. So I'll just come here, right click, new measure. So I'll say returned sales is equals to the sum of the returned amount. So let me just click on new measure here. Then we have the net sales. So our net sales is equals to what? Our gross sales measure minus our return sales measure. Then let's also create an order count. So the number of orders. So for this, we'll use the distinct count function. And we'll use the distinct count on what? On the order ID of the fact sales. So that will count our number of orders, our order count. And we also want to create a gross profit. So our gross profit will be what? Our sum of the gross profit column. Then finally, we have our gross margin percentage. So our gross margin percentage would use the divide function, and we'll divide our gross profits by the net sales. All right, so now we have our measures. So let's visualize our net sales in a card. So we have our card visual. So let's bring in our net sales. All right, so we have 22.4 million. All right, so now let's test our role playing dimension. So we have the order date and the what ship date. So by default, our net sales is basically what our net sales by what order date, because the order date is the one taking the what the active relationship. What if we want to get what our net sales by what? By ship date. How do we do that? We do that by using the what? The use relationship what function. So remember, our inactive relationship is what automatically what switched off because we can only have what one active relationship, and that is already between the what the order date and the what fact sales. So now let's say we want to get our sales by our ship date. We need to find a way to what temporarily turn on that what inactive relationship, and that is what the use relationship what function allows you to what to do. So now let's try to get what our sales by what ship date. So if we come under the measures, new measure, and we say what sales by ship date. So to get this, we have to use the calculate function. So the calculate function allows you to what to modify the context of your what your measures. So since we want to change the context and we want to apply the other relationship, we have to use the calculate. So we say calculate. So what do we want to calculate? We want to calculate what the net sales for the ship date. So we want to calculate the net sales, comma. So now the filter is what we want to use the use relationship function. Right. So when you click on use relationship, so we see the definition of the function here, right? So this definition is that what it specifies an existing relationship to be used in the evaluation of a DAX expression. The relationship is defined by naming as arguments two columns that serve as endpoints. So you use the relationship. So now you have to specify the relationship that you want to use. So the relationship, so you can specify anyone first, right? But it's usually good to also go from dimension to fact. So in our dimension table, it is the date key. So it is the dim date key column. That is our primary key in our primary key in the dimension table of dim date. Then you put a comma. Then the second endpoint, which is the second column, which is our foreign key in the fact table, is the ship date key. So now we close the bracket and we hit enter, and that gives us our sales by ship date. So let's bring in. So it should give us the same thing, I think. Yeah. But let's see if we can use a filter to see the difference. So let's bring in a button slicer and let's bring in the month. So let's bring in the month name. All right. So let's select April. Exactly. So now in the month of April, we have different values for the net sales and the sales by ship date. So when calculating the net sales using the order date, we have 1.9 million. And when calculating the net sales using the ship date, we have 2.02 million. That is the importance of having more than one relationship, because sometimes you also need not just the sales for when the product was ordered, you also need the sales amount for when the product was shipped. That is how you can create multiple relationships between your tables, and at the same time use the use relationship function to temporarily turn on the inactive relationship you created. All right. Okay, so now let's look at the do's and the don'ts when it comes to data modeling. So these are just little habits that make your data modeling easier and also makes your work more reliable. So the first do or don't is hiding your foreign columns from the report view. So the reason for this is because because nobody needs to see them. So these columns might look normal at first, right? Because they are just IDs. But when you start working with sensitive data, these columns, they stop being, they stop being ordinary values and they become what sensitive what data. Say for example, you are working in a country's database and you have what an NIN as what as a column. Right. So people viewing the report, they don't need to see what the NIN of what other people. So it is very, very important that if the consumers of your report do not need to see the foreign keys, you should just what hide them in the model view. So how do you hide columns in the model view? You just click on the table. You click on the table. So let me zoom in. Click on the table in the diagram, and when you hover on the table, you see this what icon that looks like an eye. So once you click on it, it automatically what hides what the column. So you do that for what all your foreign keys. So we have the order date key, we hide it. We can leave the order ID, the product key, we hide it. Promotion key, we hide it. Salesperson key, we hide it. So we can leave the ship date key and all that. So sales line key, you hide it. So once you hide it here, so you can also hide the channel key and the business event key. So it is not compulsory to them, but if they are sensitive information, you have to what hide them from the report viewers. So once you come to your report view now and you come to fact sales, you will no longer find those keys there, right? Because they have been hidden. So we didn't hide the geographic key. So now the geographic key is visible, right? So once we come here and we hide it, in the model view, and we come back to the report view, it is no longer visible. So sometimes not just your keys basically. So any important column that you don't want to delete it, but at the same time you don't want people to see it, you just come to your model view and you hide it. Then next up is to use the sort by column so that month name sorts in the right order. All right, so if we look at this, our filter, our month name starts from April instead of January. Or better still, let's use a line chart to better explain what I'm trying to pass across. So if we bring this line chart here, right, and in the x-axis, let's bring our month name. So let's try to create a month trend. So our month name. Then in the y-axis, we bring our net sales. Okay, so let's deselect this. So what do you notice? You notice that our sales starts from November, right? That's because November was the highest, which is not meant to be so. Why? Because the whole point of a line chart when it comes to a trend is to see how that value increase in a chronological order, right? So from January to December. So that is how the line chart is meant to appear, not in descending order of the value. So to correct this, we have to sort our month name by month number. So how do we do that? We do that in the model view. So let's zoom out. So we come to the dim date. So under data and properties, okay, under properties, so we select the month name, select the month name, right? Then we come under advanced settings. Then it asks you sort column by. So you sort column by by the month number. So by default, it's sorting it by the month name. But we want to sort it by by the month number, because in the data set, if you look here, in data sets, if you come to dim dates, each month name has a month number. So as we can see, March is 3. Why? Because March is is the third month of the year. So if we filter this to 1, for example, it will show us January, because January is is the first number of the year. So that is why month number is is the best column to sort your month name by. So if you come back here, so we sort the month name column by the month number. So we do that. So if you come back here, right? So if you come back here and we take out the month name and bring it back in. So month name, we bring it back in, we have exactly what we want, which is what? Our line chart in a what? In a chronological order. So now we can see how the net sales is what is trending across what each month in a chronological order from January to February to March up until what? December. So if we also choose to bring in the sales by ship date in here too, yeah, so now we can see how they are both what's trending. That is why it is what always important to sort your month name by what? By the month number. Then another best practice is to what? Is to build hierarchies in your what? In your data model. So what is an hierarchy? An hierarchy is just a ladder that contains your what? Your categories, right? So in terms of the hierarchy you want them to flow in. So it's just like a list where you have the most the largest category on top, then you are able to what drill down into what more specific categories. So let's create a category. Let's create a location category, for example. So if you come to okay, let's do it in the model view. You can also do it in your report view too. So if you come to the gym geography, I think, yeah. So if you come to gym geography, for example, we have city, country, region, and what? State, province. So with these 4 columns, we can actually create something called a geography hierarchy. So we have the region. So the region is actually the continent. Then we have the country, we have the state, and we have the city. So we can actually arrange our hierarchy in that level, so that we can use that hierarchy in the chart, and we are able to drill down into those sub categories. So how is it done? You start by the topmost category, which in our case is the region. So you come to region and you click on these 3 dots beside the column name, and you see create hierarchy. So once you click on it, it automatically gives you your hierarchy, which is in this case region hierarchy. So obviously you can always come here to rename it if you want. So I can just rename this to instead of region hierarchy, I can just rename it to geography hierarchy. All right. So now under my geography hierarchy is going to contain only the region, which is the column I used to create it. So now I can now start adding other columns within that table. So after the region, which is the continent, the next level is the country. So I'll just right click on country. Now I'll click on add to hierarchy. And I'll add it to my geography hierarchy. Then after the country, the next level is the state. So I'll come to state province, click on this, add to hierarchy, and I'll add it to my geography hierarchy. And lastly, the last one is city. So add to hierarchy, geography hierarchy. And just like that, I have my geography hierarchy. So now let's create a bar chart that gives us net sales by geography. And let's see how the hierarchy works. So let's reduce this a bit. Yeah, so now let's bring in a clustered column chart. Right, so under the x-axis, let's drag in the geography hierarchy. And in the y-axis, let's drag in net sales. Exactly. So now let's zoom in. So now it is showing us our net sales by by region, right? But since we created these chart using our geography hierarchy, we can then drill down into each of the regions to see the country, then the state, province, then the city. So we just click on this drill down button here. And once we do that, we can click on any of the regions. So let's click on Europe, for example. So once we click on Europe, it drills down into the countries under Europe. So we have France, Germany, Netherlands, United Kingdom. When we click on any of the countries again, United Kingdom, for example, it drills into the state province. So that United Kingdom, we have England and Scotland. Then when you click on any of the state provinces, it drills down further into the cities inside these provinces. So we have Birmingham, London, and Manchester. So you can also always drill up. You can drill up, drill up, drill up. Then you can also use this to go to the next level of the hierarchy for all of them. So once you click on this, it shows you all the countries. When you click on this further, it shows you all the state provinces. And when you click on this again, it shows you all the cities. So that is the point of creating hierarchies. So it gives you a more defined insight into the different categories different subcategories under each category. So instead of you going through the stress of building multiple charts you build net sales by region, then you create a new chart, net sales by country, you can just take care of all those 4 categories in one single category by using an hierarchy. So another hierarchy you can build is the dim product. So if you come to the dim product, we have the product category, product subcategory, and the product name. So to create this, we'll just right click, create hierarchy, sorry. Then we have the category hierarchy created. So we can add the subcategory to the category hierarchy. Then we can also add the product name to the category hierarchy. All right. So now let's take out the group. So for this visual, let's take out the geography hierarchy and replace it with the category hierarchy. Yeah, so let's drill up. Yeah, so now we can see the net sales by category. Then we can drill down into each category to see the subcategories. Then we can drill down further to see the product name under each subcategory. So that is what the hierarchies allow you to do when it comes to Power BI. All right. And also the last best practice is to give your tables a clear name, right? For example, dim customer are not something like this, because in the end, you're not going to be the only one using those table names. So you should give your table names that anybody can have an idea of what is going on, not just an analyst, but even a layman should have an idea what is under that column name. All right, and also the last practice is always mark your date table as an official date table. So what does this mean? This basically means that marking your date table as an official date table, so that it will allow you to carry out to use time intelligence function. Although that topic is actually under DAX, but it also falls under data modeling, because your date table is also a table. So once you click on this, so marking your date table as a calendar table or as an official date table, what it allows you to do is that it allows you to use time intelligence DAX functions like your previous year, your previous month, your total YTD, your date add, and all that. So like I said, it is a whole topic under DAX, but it is also a data modeling best practice to always mark your date table as an official date table. So how do you do that? So you just select the table here and you come here. So under here, you might see mark as date table, or you would see calendar options. So whichever one you see, just click on it. So mine is showing calendar options, and I'll select mark as date table. So I'll select on. It's asking me to choose a date column. So I'll choose the date column under the date table. And so you can see validated was successfully. So I'll click on save and done. So it is automatically marked as what? As a date table. So once I go back here again, I click on mark as date table again. So it is telling me that what? It is already what? On. So that is how to what? Mark your date table as what? As a date table. All right. So this helps you what? Unlock what? Useful time-based formulas what? When you are what? Carrying out your what? Your DAX in your analysis process. All right. So also we have what? Common mistakes to what? Avoid. All right. So the first common mistake to avoid is what? Splitting your dimension tables when you don't what? Need to. So splitting your dimension tables is just you turning your what? Your star schema into what? Snowflake schema. So if your table already comes as a star schema, just leave it like that and go ahead and start what? Building your model. Then another mistake to avoid is what? Leaving every relationship set to what? Both what directions. So this is what very wrong. So as much as possible, always try to use what? The single cross filter what direction. Then third mistake to avoid is what? Writing formulas to check before checking whether the model works. So before you start, writing your DAX, you should always check whether your DAX models are what. I mean, you also check whether before you start writing your DAX formulas, you should check whether your model is working. And lastly, bringing every column in just in case. So when it comes to this, kind of split it, because the way I work is I bring in just all the columns. Then when I'm done with my analysis, I go back to delete the columns that I don't need. So, but the whole point of this mistake is that the more columns in your data, the more work Power BI has to do. So the lesser the columns in your data, the faster your Power BI reports. So after your analysis, you can always go back to your data and take out the columns that you did not use so that your Power BI reports can work faster. And lastly, the most common mistake, right? No official date table. So very, very important. Always mark your date table as a date table. All right. So let's check if our data model is working. So this is just a way to check if your data model is working. All right. So let's come to Power BI report view. So let's delete all this. So let's bring in a matrix visual. Let's expand it. Then let's drag in the geography hierarchy into the rows. Good. Then let's also drag in some of the measures. So let me just, in case you want to practice this later. So we'll add the net sales, gross margin, and other accounts. So net sales, gross margin, and other accounts. All right. So let's zoom in. Yeah. So if what you are having in this report is like this, right? You have different values for different regions or different countries. So if this is what you are seeing, this is basically what's confirming that the data model is working. Why? Because these values here, the net sales, gross sales, and other accounts, while they are DAX measures, we got them from the fact sales table. While the region is from the team geography table. So if you are getting different values for each region, it means that there is a connection between your fact sales and your team geography. And that is a way to confirm that your data model is working. So let me show you what I mean. So if you come here, for example, and we delete the relationship, so we can just right click on the line and we delete it. Right? And we come here. What you notice? You notice that all the values are the same for all the regions and and all the countries. So if you have something like this, it means that there is something wrong in your Power BI model. And it most likely means that there is no relationship connecting the two tables. That is why you're having the same answers all through. So let's come back here and add that relationship back. Let's just do it the old way. So you just drag your primary key to the foreign key in the fact table. Yeah, so we confirm everything and we click on save. And yeah, so if we go back now, we'll have what different values, and that confirms to us that what there's a relationship between what those tables. So you can do that for the other tables. So just find a way to connect two tables together. And if you're having different values, it means that what there is a connection between the two tables. All right, so like I said, so you add the measures to your tables. So you check the numbers, right? Do they look right? Are there blanks or what repeated rows? So if something looks wrong, the model is usually the reason and not the formula. So like I said when we started, right? So it is very, very important to get your data modeling right, because every other process after that depends on how correct your data model is. All right, so a quick recap, right? So 5 things to remember when it comes to data modeling. Number 1, when possible, which is most of the time, use a star schema, right? So it is faster and simpler than a snowflake schema. Number 2, every relationship needs a clean key to keyword connection. So remember that your keys they need to have the same data type, right? So if you are going with text data type for your keys, make sure it is consistent in both the primary and the foreign keys. And also make sure that your primary keys do not have duplicates. Because if they have duplicates, you would have a many to many relationship, which would confuse not just you, but also Power BI. Then number 3, use single filter use single direction filters by default, and only use both when they are required. So most of the time, what you need is is a single filter direction, or a single direction filter. Then also role-playing dimensions, right? They need use relationship function to temporarily switch on the connection, like what we achieved when we try to get the sales by ship date. So if you want to get this, if you want to get the a measure using an inactive relationship, you have to use the use relationship function. So this is also another separate topic under under DAX. Then lastly, always check your model with using simple visuals before you trust the numbers. So like I just showed you here, using this matrix visual, we've confirmed that there's a relationship between our geography table and our factors table. So before you start building your reports, always make sure to check that all your connections are correct. So that is how to to test your model before you start designing your reports. All right, so that brings us to the end of the masterclass. So do we have any questions? Okay.
I have a question. I have a question.
All right, go ahead.
Okay, so on the matrix visual, please can you go back there? Can you go back there?
All right.
Sorry. Yes, the breakdown I see, was it because of the hierarchy created on region? The breakdown that
yes, absolutely, because of the hierarchy.
So if I do it and do not create hierarchy, it won't break down like this on the visual.
Let's find out, right? So let's drag in just the region. So if you drag in just the region, you have only the region. Then let's drag country under it. So it should break down. Yeah, it will break down, right? But what the hierarchy allows you to do it allows you to drag in everything at once, instead of dragging it in one by one. So if you drag it one by one, so far they are in the same table, right? It would give you a breakdown. So for example, we have region and country. So if we click on the plus sign, it will drill down into country and give us the insights for each country. But compared to the hierarchy, if you bring in the entire hierarchy at once, So with this, we can drill down into the country, into the states, and finally into the cities.
Okay, okay, understood. My second question will be, is this model a star schema?
Yes, it is a star schema. So it is a star schema. Looking at the diagram, so let me zoom out. So if we look at the diagram, so this measures is just an additional table. So if we look at the diagram, right, so it is having what? One fact table directly connected to what? Multiple what? Dimension tables. So yeah, we might have a lot of dimension tables, right? But so far it is one fact table in the middle connected to what? Multiple dimension tables. It is a what? A star schema. So it's similar to something like this, right? So you have one fact table connected to what? Dimension tables. So it is a fact schema. I mean, it is a star schema, sorry.
Okay, so for Snowflake, we have more than one fact table.
No. For Snowflake, you usually have one fact table too. But the dimension tables will be what? Would be subdivided into what? Further dimension tables. Huh?
Will be connected to each other.
No, not basically connected to each other. So say for example, under this dim product, right? We have another product that is what? Dim category. Right. So let's say for example, we have a product that is dim category and what? Dim product. So obviously the products are under the what? The categories, right? So that means we would have, so let's say for example, how do I explain this? So it's basically when it comes to the Snowflake schema, you have what? A dimension table that is what? Divided into what? Further dimension tables. So similar to what we have in this diagram here. So we have the singular fact table, then you have the dimension, then those dimensions are what? Broken down into what? Further dimension tables. That is what a Snowflake schema is.
All right.
Once you have,
I get it.
Once you have, yeah, so it is actually possible to have multiple fact tables. So that is called a galaxy schema, basically.
Okay. Yeah. Now, another question will be, you say you need to mark the date table. Is it best practice or because of this SSD? It depends on the data you're working on. Do you need to mark
it? Is actually, yeah, it is. It is best
marking
practice.
it does it mean you're turning into a calendar table?
Yes, in a way. So when you mark your date table, you're basically preparing it for what? Time intelligence analysis, right? So say for example, you want to get your net sales for the previous month, you need a time intelligence function. And those time intelligence functions, they do not work unless what? The date table is what? Marked as a what? As a date table. But sometimes you may not have the dim date table, right? So sometimes you might not have a date table, then you would need to what? Create what? Your own calendar table. So even if you create your own calendar table, you still have to what? Mark it as a what? As a date table. So marking it as a date table, it just allows you to what? Perform what? Time intelligence functions.
Okay, my last question, please. And that will be on, okay, when you brought in this data, I see all these dimensions created already. What if I have a data that they are not created, that is just one full data that I need to factor all these dimensions by myself?
Okay, so you're talking about if you're working with if giant flat table.
Yes.
Okay, that is a whole other topic. So if you're working with a dimension table, if you want to convert it into fact and dimension table, it means you have to normalize the data. So it means you would have to, divide it into
duplicate them.
Yeah, so you have to duplicate them, then you have to delete the rows and delete the duplicates in. So for example, if you are working with one giant fact table, since we have in this case 8 other dimension tables, so you would have that. It's actually a very long process though. You would have that one giant fact table, you duplicate it 8 times, then you will now start turning those other 8 duplicates into what? Dimension tables by deleting the unnecessary columns and also deleting the duplicate rows.
And then you now rename them.
Yes, you now rename them. Then
all right. Thank you. That suits my question.
All right. So any other questions? Okay, Glory.
Hello, good evening, sir.
Good evening.
So my question was, the primary keys, are they always in the facts table or they are usually in dimension tables? And same as the foreign keys, or do they have a specific table or they can either be in both?
All right. So all tables should have a primary key, right? So what the primary key does is that what it serves as a unique identifier for what each row in your table. So every key, whether it is, every table, whether it is a fact table or a dimension table, or even a sub-dimension table, should have what a primary key. So it doesn't depend whether it is a fact or a dimension table. It should have what a primary what key. Now your foreign keys are found only in the fact table. So they are basically dimension keys that allow you create what. So they're basically dimension keys in your other foreign tables. So if we go to, where is our fact table? Yeah. So this is our fact table, right? So this is the primary key for our fact table, the sales line key. So it should not, so your primary keys should not have any duplicate. So for example, if I should filter for just this one, I should get only one value. So your primary keys should not have duplicate, but your foreign keys are meant to have duplicate because they appear multiple times, right? Since this is the sales table, and each product key represents each product. So obviously, you when it comes to sales, you will definitely sell one product multiple times. That is why it is expected for your product key to appear more than once. So that is why we filter for product key 1, it should appear multiple times. Exactly. So you can see that it's appearing multiple times. So yes, your primary, so every table should have primary keys, while foreign keys are found only in fact tables.
Oh, all right. Thank you very much, sir. And for the last question, please can you
All right.
explain the difference between a gross sale and a net sale?
Okay, so a gross sale is the total amount they made, right, without removing anything, right? So I'm actually not, I'm actually not a business person myself, but it's just like a general definition. So a gross sale is the total sales they made, right, without removing anything from it, like the tax, the number of return amounts. So without removing any deduction yet. So the actual amount they made is called what? The gross sales. While the net sales is what? Is when you've removed all the deductions from it. For example, the you remove the tax, you remove salary, your worker salary, you remove tax, discounts, and all that. So what you have left is the net sales. So it can vary from organization to organization. So for example, for this data, our net sales is what? Is the gross sales minus the return sales. So when we remove the return sales from the gross sales, we have net sales. So your net sales is basically what you have left after you've taken out the necessary deduction you need to remove.
Oh, all right. Thank you very much for answering me. God bless you, sir.
Amen. You're welcome. Okay, Samson.
Yeah, hello, good evening. So thank you very much. To talk my straight to the question. My question is number one.
I'm not hearing you.
Okay, can you hear me now? Maybe it's my network. Hello,
Yeah, I
can
can
you
hear
hear
you
me
now.
now? All right. So I want to know. I want you to restate the reason why you turn off the eyes icon in those dimension table. I want you to restate the reason. Number two is that I saw that date has two relationships. So I want to ask concerning dimension table, is it possible to have like a two relationship with fact table? The kind of scenario, like stating a real life scenario as touching that. And lastly, about my question is in terms of, I saw that your column headers are well stated. So is it like that in a normal real life cases? Thank you. I don't know.
Okay, so let's answer your questions one by one. Okay, so the first one is you asked so can you repeat it?
Thank you.
Okay,
I
like
talked
why I
about the
turned off.
Yeah.
Okay, so so the reason why I turned it off is that it is actually not compulsory, right? So it is more of like a best practice. So say for example, you are working with bank data, right? So in bank data, you'll be dealing with very, very sensitive data. So when it comes to bank data, you won't be working with all these, channel key. You'll be working with actual sensitive IDs like BVN, NIN, which other one? BVN, NIN, transfer ID. Those are actually, very, very sensitive words, primary and foreign keys, right? So while you need them to join your tables together, for example, in your bank data, you probably have a separate table for transfers. You will have a separate table for customers also. So why you will need those, keys for what to join your tables together, like for example, the customer ID in the bank data might be the BVN, for example. Why you need the BVN to, connect your tables together? Whoever is consuming the report does not need to see that BVN, right? So there are two ways to prevent someone from saying something when it comes to Power BI, right? You either delete it or you hide it. So now deleting is not an option, right? Because you still need them to create relationship between your tables. So the other option is to hide it from the report view. And that is what we did here. So hiding it here means that when we come to the report view and we look into here, we want see those keys. So it's not just your keys, basically. Any other column that you know that it is sensitive, right? And you do not want to delete it. You have to hide it. Not even just your columns, even your pages, for example. For example, if you are creating a report and you have a tooltip page, so a tooltip page is not meant to appear when you finally publish a report, right? But it's still part of the report. So what you do is you hide it instead of deleting it. So anytime you have any information, not just keys now, you have any column that is sensitive and you do not want people to see it when you publish a report, you just hide the column in the report view. All right. So what's the second question?
Yes, thank you. My second question is, I was talking about how date has two relationship with the fact table. Like, is it possible for dimension table to have more than? Thank you. Yeah.
All right. Okay. So the reason why the date has two relationships is because in the fact table we have two dates, right? So remember, this is a sales data set, right? So obviously, if you want to order something, there's a date you ordered it, and there's a date, it was shipped to you. There are even some data sets that would have three different dates, right? Some would have the order date, the ship date, and the delivery date. That is three different dates, right? So if you want to get insights from those three different dates, you have to create relationships to those three different dates. So in this case, we have only two dates, right? So we have the order date and the ship date key. So if you want to get insights from, so obviously to have a relationship between these two tables, we need a relationship, right? So we used our order date as the active relationship. So now what now happens when we want to get insights about the ship date to? Do we now come back here to now switch back? That is wrong. Or say, for example, in the same report, you want to have insight from both the order date and the ship date at the same time. So what do? It means you need to have multiple relationships. But in Power BI, you can only have one active relationship between two tables. So that means every subsequent relationship has to be inactive. That is where the concept of inactive relationship comes in. So anytime you need to use that inactive relationship to get a value. So for example, we want to get the sales by ship date. You have to use the use relationship function to specify that particular inactive relationship. So do you understand now?
Yes, I understand. Thank you.
All right. So
Yeah. So
I think you have one more question.
Yes, I was talking about the column header. Like, is it always like that? I saw that everything is well stated and is actually connected. You don't have stress figuring out which one is foreign key, which one is primary key from the first two. So everything is just fine. So is it always like that?
Yeah.
And
It depends. It depends on your data source. So, for example, this is a challenge data. So data came in this way. So that's why it's like that. So also, if you're working for an organization, it's most likely the structure because you already have the data engineer that's is in charge of creating the data and making sure it is ready for analysis. But it depends on where you're getting your data from, right? So if you are getting your data from somewhere where they don't really care what the column headers are, your data might come in anyway, basically, right? But there's always something called a data dictionary. So that tells you what each column is all about. So that way you can always rename your data. So there's even another opinion of people saying that, when naming your columns, you don't have to put the name and the fact. So, but that's just an opinion, right? So, but some other people also say that, it is also best practice to include the fact and the name so that in case someone else is working on that same report, the person can know that, okay, this is the fact table and okay, this is a dimension table. So it all depends on your data source. So sometimes your column headers come in clean and sometimes they come in dirty. And as part of your data cleaning, you would have to clean it up and give it proper descriptive names. All right, so I think I've answered your question. Okay, so Moses.
Good evening, Mr. AbdulSamad. Thanks for today's.
Good evening.
Yeah,
You're welcome.
A Galaxy schema. You mentioned that earlier when you were answering, I think it was Kevin back then. So you said the Galaxy schema is a schema where you have multiple fact tables. So with that, I guess you're going to have multiple dimensions as well. But my question is, can there be a scenario where those fact tables are related to each other? And if it is possible, can you give an example?
I don't. So the whole concept of fact table is meant to house your numbers. So when it comes to a Galaxy schema, your fact tables should not be connecting to each other, right? Because on a normal day, you're meant to have just one singular fact table, right? That is housing the measurable metrics. So if you're having, multiple fact tables, that means the other fact table should be housing a different set of numbers. Although two fact tables can connect to the same dimension table, but in the normal scenario, I don't really know if it's possible. But in a normal scenario, two fact tables should not be connecting to each other, although they can connect to the same dimension table. So for the scenario, let me see. I think I've worked on something similar. Let me check my projects. I think I've worked on something similar. Let me try to remember the name. Is it something related to health? Is it this one? Let me see. No, I don't think it's this. So let me just check. Okay. I can't really find where it is. I don't know. I'm trying to remember the name of the report, but I can't really find. There's something I did a while back, so it makes use of a Galaxy schema. But yeah, so it's basically the same scenario, right? So you connect, you see the same connect from your dimension to fact table, but the only difference is that, you know, in this case you have multiple fact tables. But yeah, the fact tables should not connect to each other, but the multiple fact tables can all connect to the same dimension table. All right, so any other question? I think someone else raised up behind. Okay, so let me paste the link to the slide and the data set. So in case you want to, you know, go back to practice on your own.
Mr. Abdulsamad,
So the Google Drive.
Mr. Abdulsamad, we'll be making it available on YouTube as well. We're making it
all
available
right.
on YouTube.
Perfect.
Thank you.
All right. All right. So okay, so I guess I can stop sharing now.
Okay. Yeah, so that's been I'll say not a really long day. Thank you so much, Mr. AbdulSamad, for that insightful, practical, and engaging section. With really thank you. Thank you very much, Mr. AbdulSamad. I don't have been muted. Thanks so much, Mr. AbdulSamad, for that insightful, practical, and engaging section. We truly appreciate the time, the knowledge, and the knowledge you have shared with us today. And then I personally believe that everyone who participated today has gained valuable insights that they need to apply in their Power BI and they need to apply in their data analytics journey. So please, guys, let us all give our facilitator a big round of applause. Guys, let us give our facilitator a big round of applause, guys. Guys, let's give him a big round of applause. He has really done well. Let's give him a big round of applause, guys. Yeah, so thank you so much for that section, AbdulSamad. Also, before we close, and likewise to everyone who joined us today, thank you for your time, your participation, and your active engagement throughout the masterclass. Your presence is what keeps this learning section meaningful. Yeah, so I think it's very, very important. And before we officially close, I think our admin has sent a Google form on the group asking everyone to, as I've informed you guys earlier, so let us take a few minutes to complete and fill the feedback and testimony form. Right. So let us just take a few minutes to complete. And so let me so we are going to stop the recording. So let us take a few minutes to complete the feedback and recording form. So the feedback and the recording form is on YouTube. Yeah, the admin can paste the link again. It's five. Yeah, so the form has been sent again, guys, so we can all ensure that we fill the form. And likewise, another thing also I want to share with you guys is a bootcamp coming up from our masterclass. Yeah, Mr. AbdulSamad. So you are going to really learn well. Let me tell you something. It's better for you to pay to learn than learning halfway, than learning half journey. Right? I can guarantee you guys, if you subscribe to this, right, it's 50,000 naira. if you subscribe to this, in 6 weeks, everything you really need to learn about Power BI. Even though it will get to a point in time of which, if we have masterclass, it is Mr. somebody himself that be recommending that let us call this, let us call one of my students, let us call one of my students, guys. So you have a lot of things to learn, guys. You have a lot of things to learn. You can see what you can see what is here. You learn a lot of that, time intelligence. You learn wireframe, the report, the design, storytelling, the Power BI service. So CodeSphere Hub will be posting it on YouTube for everyone that wants to learn. And likewise, if you check Mr. AbdulSamad's LinkedIn, he has a lot of data sets. So he has a lot of dashboard, of which me myself, I'm always inspired about the dashboard. Right. So I will post it on the group. It's available on the group for anyone interested. Right. So ensure you subscribe to the right course for you to learn effectively. You already know a data analyst that doesn't know Power BI is not yet a data analyst. You need to know Power BI. Power BI is essential. Power BI is not something of which you just overlook. You need to understand each and every corner aspect of Microsoft Power BI. So ensure you subscribe to it. So it's available. Ensure you I don't know if it's affecting is either any mode of payments wise, or I don't know, but ensure the best form is just for you guys to subscribe to it and have an effective learning. So thank you so much, guys. So let us see, guys. Let's see any emoji if you guys have filled the form, the feedback form.